Bingo. Good morning, everyone, and thank you for coming to our lunch and learn session. I'm going to give it a moment just to let you barrel through the virtual front door. So again, thank you for taking, hopefully you've got a sandwich or a cuppa and dialing in for our lunch and learn. Actually, our first one for 2025. So just giving it another moment. You can see we're expecting. We've actually got over 250 people registered for this session. So the numbers are filling up pretty quick. I'll wait till we sort of hit that maybe halfway mark and we'll get started shortly. Hey. So by my count, I think we're approaching almost 100 attendees. So a pretty big audience out there. So for those who've made your way here, welcome to our 2025 ecologiQ Lunch and Learn series. This will be running for the month of May, hence it's Lunch and Learn Mayhem for those who came to the who found your way here. Today's session we'll be hearing from the M80 Ring Road Completion project team who are delivering the works of North East Link project. My name's Doy Lee. I'm the industry manager of ecologiQ. I'll be your host for today, and my co-pilot. I'll let Lily Rose introduce herself.
Hi, everyone. Welcome. My name is Lily Rose. I'm a senior industry advisor in ecologiQ, working with Doy. Thanks so much for attending. I'm really excited to kick off the lunch and learn today.
Fantastic. Thanks, Lily Rose. So let's get cracking. Before we get started, although we're meeting virtually, we still meet on traditional lands. So I'd like to acknowledge the traditional custodians of the lands from which we are meeting from and dialing in from. So for me, I'm dialing into you from the lands of the Bunurong people of the Eastern Kulin Nations. I'd like to pay my respects to elders past and present and future as well, and any First Nations or Aboriginal people that we might have with us here on today's session. So just a really quick intro. I assume you know who ecologiQ are, but in case you don't, ecologiQ is a Victorian government initiative. It's actually been in place since 2020, and it is about transitioning using the big build and the major road rail and tunneling projects to transition the industry towards a circular economy and making recycling, not the highest priority, but at least at the forefront of people of our construction practices to make sure that where we can make use and avoid or recover our resources, that we do that as the highest priority. And how we do that is through the Recycle First policy. So projects like the M80 project here at Northeast Link have a recycle first requirement, and what that means is that the project is looking at optimizing use of recycled materials, and secondly, through different stages of its delivery and completion, we'll be reporting on the quantities and volumes of recycled materials used. And I'm happy to let you know to date, since the policy has been in effect since 2020, we've actually had over 3.4 million tonnes or 2 mcg's worth, I've been told, here in Melbourne. It's can fill 2 mcg's worth of recycled materials. There are 36 projects that have the policy in place, and with the commitment in quantities, there's actually 3.1 million tonnes of materials committed to be used so far. And I think some of those you'll hear about here today from the M80 project team. Without further delay, I'll now hand over to the star of today's show. I'd like to introduce to you Sasika Perera, Sustainability Engineering and Integration Advisor with the M80 Ring Road Project. And we have John Searle, Inventor Director for Robovoid. So Sasika, over to you.
Thank you so much, Joey. I'll start sharing my screen. Hope you all can see my screen.
Not yet.
Not yet.
There we go.
Can you see the big screen?
Yep, it's in presentation mode. We're
awesome.
Good to go.
Great. Thank you so much, Joey, for the introduction, and good afternoon all, and welcome. Thanks for joining with us today. We are excited to present two Australian first innovations fueled by the excellence in the supply chain and the M80's collaborative approach. Without further ado, let's start with the acknowledgement to country. We at M80 Ring Road project acknowledge the Wurundjeri Woi Wurrung people as the traditional custodians of the land on which the project stands, and respectfully recognize elders past, present, and emerging. We also acknowledge the traditional custodians of the lands across Australia where we conduct businesses and their elders, ancestors, cultures, and heritage. The M80 Ring Road Alliance, consisting of Actiona, Maca, and ACOM, is delivering the northern component of the Northeast Link program. I would like to share a very brief overview of our project scope. If you want to know more about our project, I would recommend looking at our website. So we will complete the nil connection between the M80 to the tunnel section up to Richard Avenue. We will add new lanes, introduce 2 new interchanges, one in M80 interchange in Greensboro and the another one in Grimshaw Street in Watsonia North. We will deliver 10 kilometers of new and upgraded walking and cycling paths, promoting active transportation. We'll have 8 new and upgraded bridges, including 2 landscape bridges in Elder Street and Watsonia Road. We recently completed one of the longest rail occupations successfully in Hurst Beach rail line. And once completed, we'll have over 4,000 trees planted as a part of this project. M80, we are all about creating a fundamental shift in how sustainable infrastructure projects are delivered. Our approach centers on the 3 key focus areas to reduce the material life cycle impact. One is the design efficiencies and minimizing the material usage. And then second one is the maximizing the recycled content and promoting the circular economy, as we just explained, and encouraging the use of sustainable certifications such as EPD and SSA to enhance the credibility of the products that we are using. The 2 products that we actually going to talk about today, Robovoid void formers used in retaining walls and JFRP bridge decks, are actively aligning with the United Nations Sustainability Development Goals, such as responsible consumption and production. So let's move towards what has actually helped us to achieve these amazing outcomes. The supply. It's a very quick rundown of the process that we have used, and that helped us incorporating these sustainability initiatives into our design. Early on, we recognized the supply chain as a key catalyst for change in delivering sustainable infrastructure. So we spend a lot of time proactively communicating with the supply chain during the pre-bid, bid, and design phases. We used opportunities like ICN events, ecologiQ supply showcases, and other industry forums to effectively communicate or proactively communicate our requirements to wider network of suppliers. In the photos here, you can see our team at a supply showcase organized by us, where our team were able to directly communicate with the supply chain to harness the excellence in the supply chain. It actually helped us have the early engagement with our supply network, which was crucial for the sustainability integration in design. To avoid design changes in the later part of the project and optimize any sustainable solutions which could be incorporated into the design at that point. Also, we had a strong focus on integrating sustainability into procurement because our procurement team is the face of the project, directly engaging with our supply chain. All this process, the quick process that I have given the rundown, has been fueled by the collaborative approach. I would like to give a huge shout out to our engineering, design, and procurement teams for championing this collaborative approach and delivering greater outcome for the project. So where possible, instead of going for standard prescriptive tenders, we have gone for descriptive tenders, which is widely known as performance-based tender approach, which gave us the opportunity to trial new products, processes in our project. We always requested our supply chain to challenge our process and bring innovative ideas and products to the table. Our engineering team, which is deeply aligned with our sustainability requirement, has been constantly working with the supply chain to trial innovative products and provide guidance throughout the approval process today. Suppliers really got the benefit of working with a tier one company who is passionate and willing to collaborate. So instead of like having the standard or the BAU engineering design approach, our engineering team actually has taken an eco engineering approach, working with the suppliers to deliver some great outcome for the project. We also acknowledge and recognize suppliers who has gone above and beyond throughout various platforms. This is a great opportunity to highlight Robovoid, who has provided us with an innovative solution for our retaining walls. So Robovoid, which is made of 100% Victorian recycled plastic. I would like to request Dr. John Steele to talk about the Robovoid. Over to you, John.
All right, thanks, Sasika, and yeah, thanks to ecologiQ for giving us the opportunity to be part of today's session. It's great to have the Victoria government and the big build projects really enthusiastic about sustainability, and as well as its appointed contractors and consultants, and through that we've been able to engage early in the project, as Sasika's mentioned, and Sasika was one of our early contact points, and has really helped drive this innovation into the project, and we really thank her for that. It's taken a lot of persistence, and there's always a few challenges along the way, but we've managed to successfully address those and get through to a great innovative, sustainable solution. So what we've been looking at with Robovoid, well, to explain, Robovoid is a void former that allows us to use less concrete in construction. And in retaining walls, it's particularly beneficial to use because, as most engineers know, retaining walls are mainly a flexural element, and so they're in bending. And in those elements, a lot of the concrete in the middle of the section is not required for structural purposes. So this is a great opportunity to incorporate our technology. And just to begin with, to look at the benefits, as I'm sure many of you know, in situ concrete is a fairly slow process, and the preferred way to do retaining walls is often using precast, which is the middle option. Probably the main downside in terms of logistics is the weight of the units, so they're quite heavy. So with the Robovoid solution, we're able to introduce void formers into the precast elements. That's on the right, and typically we can reduce the amount of concrete by about 30%, sometimes more, and that's great for logistics because it's lighter elements to lift. You can put more elements on a truck, and you can use smaller cranes. So there's lots of benefits to having lighter elements, but it's also the sustainability benefits. So we know that CO2 emissions are quite high in relation to concrete. So the less concrete we can use, the more CO2 reductions we can achieve. So we'll just go on to the next one. So just to explain the Robovoid product, it's a 100% recycled plastic void former system, which is a bit like a kit of Lego, which clicks together and it creates boxes or void formers that go into concrete. We have a range of sizes of void former, and we can create voids from 50 millimeter up to 300 millimeter when they're joined together. And the width is currently 200 millimeters, and they click together side by side as and you can create any size void former you want. So maybe move into the next one. So this is our production process. It's local manufacturing. Our factory is based in Thomastown, and we use Australian sourced recycled plastic. The plastic we get comes from GT Recycling in Geelong, who recycle waste plastics around Victoria. Our production unit is actually benefits from solar power on the factory roof. So the amount of embodied energy or CO2 in our product is very low. And so in the production process, the plastic heats up to about 200 degrees Celsius. So it's quite a low temperature process compared to production of cement, which is typically at 1400 degrees. So yeah, for every kilogram of embodied emissions, we can save about 30 kilograms in the construction. So that's our production unit, injection molding process, and on the right there shows a range of box sizes that were delivered to a precast factory, to just give you a bit of an idea. So how it works in concrete, if you follow the red arrows on the left, that's the path that the concrete takes through the void former. So that you pour from the top, and the concrete flows down through the cones, spreads out underneath sideways, and it spreads sideways across the top as well. And the voids are in between the cones. And then what we often do is in between the boxes, we have a solid rib of concrete. And they're normally required to deal with the shear strength depending on the loads. So as I said, the concrete typically reduces by 30%. CO2 emissions substantially reduce, and there's logistics savings, fewer deliveries, lighter lifting, and less weight on a supporting structure. This is a typical connection detail between precast planks. So not only is our void former system act as a void former, it also creates connections between precast elements. So in this case, we can fill the void locally on site with in situ concrete and fill the joint with reinforcement bars, and we get a strong connection between panels. So this joint detail can be used for flat slab structures or between wall elements. Not so relevant for the retaining wall structure, but just more generally, this shows the versatility of the system and what else it can achieve. So strong connections, very little work on site, or most of the work's off site, so you get a very fast build process. You can move on to the next one. So in the Northeast Link project, we've been heavily involved in developing the system or the application there, and we've looked at a wide range of retaining wall heights, some up to I think over 6 meters, and some as low as about 2 meters in height. So as part of that process, we do a lot of detailing, detailed engineering analysis. If you want to move on to the next step, Sasika. Excellent. Yep. And analysing the retaining walls to demonstrate the performance requirements can be met. And so we have to get quite heavily involved in the details, because with any new product, there's a lot of scrutiny, and we really need to demonstrate the adequacy of performance in all aspects. So the left is a finite element analysis, looking at the impact loads, and on the right, just looking at the joints using strut and tie methods. There's a few examples of the analysis. Going to move on. Yep. And so we've looked at a wide range of heights of retaining wall, and typically we find that the mass reductions are greater for the taller walls. If the wall's only 1 meter higher, it's probably not worth putting the void formers in. In fact, they don't actually fit in because the wall's too thin. But for thicker walls, taller, thick walls, we can actually fit in bigger void formers and save nearly up to 40% of the concrete. So as part of the engagement process, we worked closely with Westcon, and they kindly offered to conduct some production trials at their facility in Melton. And so we just wanted to make sure that the production manufacturing process would go smoothly. So some good learning there around the reinforcement detailing and the assembly sequence, and that's been incorporated into our design process going forward. And a key part of the production trial was ensuring that we could get good consolidation of the concrete. So for this one, we used 180 slump concrete with 30 cement replacement and a vibrated mold, and excellent compaction was achieved there. And you can see some of the units that were produced, and they look a lot like all the other units that were made without the void formers, so you'd never know the difference. And Sasika and her colleagues were there to witness the trial, and just to make sure it was all going well. So apart from void form, retaining walls, it's a very versatile system. So you can use it in slabs and ground slabs, suspended slabs, even facades. So we've got some other projects coming up soon as well, where it'll be used in those applications, and we'll talk about them in the future. So thanks, Sasika. I'll hand it back to you.
Awesome. Thank you so much, John. This initiative has been really a learning curve for us, and the collaborative approach that has been given, or like the technical knowledge which has been given by Robovoid and John was extremely important and crucial for the success of this trial. And we are still hasn't installed this particular product on site. We are hoping to get this installation going from November this year. So we probably will be able to provide more information on the success of the actual constructability of the product after that first installation. So let's move into the next part of this presentation, which is the glass fiber reinforced polymer composite bridge decks made with 100% recycled plastic PET foam core. And this has been designed and manufactured by SIS Sustainable Infrastructure System using their patent technology from their mother company, Netherlands, Infraco. Please note that the final stage of the obtaining TTP approval for the use of this product in our project is still pending. And I would like to acknowledge and celebrate our engineering managers, Tim Lennon and Paddy Reid, for their effort in driving this extremely challenging initiative. Also, I would like to acknowledge the collaboration of SIS, which was instrumental in driving this initiative forward. So we have Nick Bolton from SIS attending this session today. So if you have any questions, please feel free to put it into the chat. We'll get those answered through Nick and myself. So let's move in. So what are the benefits we can realize if we use the GFRP bridge deck? So it will provide the 100-year design life, which is important. The maintenance and inspection regime comparable to the conventional decks. So there is nothing extremes or nothing extra is required. Less whole of life costing due to the reduced capital and demolition cost and comparable maintenance cost. And using 100% recycled Australian soft plastic for the core, which is the 80% of the deck, which is something we really wanted to be realized, and then 100% end of life recyclability. Another important thing to notice of this bridge deck is it is 10 times lighter weight compared to the concrete deck and provides the high strength, resulting in the reduction in the size of the structural components. So we can actually optimize the substructure and the rest of the superstructure, like the arches and stuff like that, because it is lightweight. And also it reduces the fuel consumption during the transportation and lifting equipments, because the weight is extremely low, and it can be manufactured off-site and reduces the on-site insulation exposure, which is helpful for in terms of the traffic disruptions and other construction programming constraints. Initial calculations of the CO2 reduction is actually coming up to 50%, but please note EPD is in progress. We'll share those with more credible information once the EPD has been finalized. The product. What is the product? So the product actually is the deck itself. So I'm pretty sure that most of you have heard of the GFRP rebar. It is the bar, but this is actually a full deck made of the GFRP. So it actually has the wearing surface where you can see on top, and then you have the GFRP structural flanges and beds, which is in a Z shape. So it's the red line in the middle photographs. And then the PET foam core, which is made of 100% recycled plastic. So what is GFRP? GFRP is the composite material made of polymer matrix reinforced with glass fiber. So as I mentioned, SIS is using the incorporation technology to manufacture this in Australia. So the actual GFRP EZ flanges has been made using the glass fiber sheets and locally sourced resin. And then PET foam is made from 100% recycled Australian soft plastic. So I would like to talk about the wearing surface and what are the benefits it can actually add to your urban design aspects of your project. It's actually can have various colors and patterns. You can have various types of surfaces and high quality texture finishes, and it actually provides quite a lot of urban design flexibility. For this for our project, what we have proposed is the multi-layer deck coating system. So we'll have a non-structural coating providing the UV resistance, and we will achieve P5 SIP rating in accordance with the Australian standard, and also this wearing surface will provide the easily maintainable surface during the life of the structure, which is very important. Where will it be used? So as I mentioned, we are still in the final stage of getting the approval for these locations. But once get the approval, it will be an Australian first use of GFRP bridge deck over a freeway. And we have proposed to use that in two particular locations, one at Macona Street SUP overpass, which has actually length of 85 meters, and the GFRP have the maximum thickness of 240 millimeters. this actually will be supported with the arch structure. And then the next one is the Nell Street SUP overpass. It actually has a span of 64 meters and the maximum thickness of 240 millimeter thickness in the actual GFRP bridge deck. So we will have the 240 thickness, the maximum thickness in the crown, and will maintain the 2% cross-fall for the drainage aspects of this bridge deck. So the challenges, which was extremely important noticing and acknowledging as well. So it has been actually introduced to the project in December 2022 when we were doing the top development. And it actually has been a 2.5 years worth of effort, and it's still continuing. And that's why it is really important to celebrate the engineering managers who have been like constantly putting their effort, making this this initiative actually very, very important initiative, and trying to get the necessary approvals from the authorities. So the very first challenge was the standards. The current Australian standard AS 5100 doesn't allow using GFRP members. Just doesn't have the standards described to use the GFRP members in the bridges. However, there has been an early commitment to use the new standard developed to address these issues and use the Austroad specification ATS 5880, which was issued in November 2023 to satisfy that requirement. So there was extensive testing requirement to meet the AST 5880 and to confirm the 100-year design life, which has been successfully completed by SIS using University of Southern Queensland. And then, as I mentioned, approval, which is still going, incorporating all the stakeholders and SMEs inputs and building confidence in the product. That was extremely challenging because what we know already is the conventional concrete decks, but the GFRP deck is pretty new to Australian construction industry. So developing that confidence in the SMEs and the stakeholders and providing necessary documentation and incorporating their inputs and their comments into this design was extremely crucial, which has been successfully managed by our engineering team. The learnings, the collaboration, as I mentioned, has been extremely crucial. Open book approach with M80 engineering team and with SIS. That approach has been extremely instrumental, where SIS can get the guidance and support from our M80 engineering team to actually go ahead and proceed with the necessary requirements made by the SMEs. Early identification and engagement with the suppliers, as I mentioned, and then like trying to get the necessary approval through the collaboration with the stakeholders and SMEs. So another important learnings was when we first met SIS, they were importing the core, the peat foam core from overseas using, again, recycled plastic, but it is actually overseas waste. However, within these 2.5 years, SIS was able to develop a process where they can actually use the Australian soft plastic to manufacture that PET foam for the core, which is the 80% of the bridge deck. And they have their the conversation going with the Woolworth and the Red Cycle, so that they can actually use that particular product to manufacture the PET foam using Australian soft plastic. And with this collaboration with M80, SIS actually got the confidence to have the conversation with Victorian government, and then having the next step of having a SIS facility in Victoria, which is extremely important for a Victorian infrastructure industry. Another learnings, this actually has been really highlighted by our engineering team and as well as from Nick from SIS, which is the GFRP bridge deck actually can be can be stimulated to have the similar thermal coefficient to steel. So then there will be less risk of your connections and your expansion joints and stuff like that. So if our engineering manager, once we get the actual necessary approval, will have the further talkings of this particular topic in various forums in future, and please stay tuned for those ones. That's it from me for the GFRP. I would like to hear from you guys what you would like to hear from us next. Because as a part of M80 Ring Road Completion, we have done we have actually implemented various initiatives such as ultra-low warm mix asphalts, calcine clay field trial using excavated spoil in situ and precast, which is coming soon, and low carbon concrete solutions for structural elements, 75% SEM up to, and then low carbon stormwater drainage solutions and temporary cardboard hoarding with acoustic properties. So please feel free to scan the QR code and provide your voting so that we know like what you would like to hear from us next. Over to you, Dewey.
Thank you, Sasika, and thank you, John. So I hope you're getting plenty of some data there, because I I'd love to find out more about all of those elements, but for our future Lunch and Learn sessions, I think it'd be great to revisit some of these topics. So my key takeaway from that is the importance of collaboration up front. I think what we're seeing here with the M80 project is, without that engagement with the supply chain, looking at what's possible, having your procurement processes being not being descriptive, but really being sort of performance-based, allows for that innovation, which is things that we're keen to see as well. So we've got about 7 minutes left. I did want to open up this session to the audience. I think at its peak we had 130 people there. We've got 121 people still on the line. You're welcome to hop in and put your questions in the Q&A. I forgot to prompt that at the start. But I think that's probably the fairest way to go through, and we can answer some of these questions together. So just going straight into the Q&A from anonymous attendee. This might be a question maybe for you, John, perhaps. Or actually, sorry, or if you know the answer to this, are there any other recyclers that recycle GFRP in Victoria or elsewhere in Australia?
Sorry, say that again. So repeat the question again. Sorry.
Yep. Are there any recyclers that recycle GFRP in Victoria or elsewhere in Australia?
So as far as we are aware, it is SIS will take the material back, and we have Nick. If you want to answer that question, Nick from SIS.
Yeah, I'll see if Nick is on the line. Is this Nick Watton?
Yes.
Yep. Nick, if you're there, Nick, you're welcome to take the mic.
Can everyone hear me?
Yep.
Yes.
Yeah, excellent. Yeah, so we our product is fully recyclable. We're actually in talks and have been for about a year and a half with GE in relation to the processing of their turbine blades. So we've developed a process here in Australia for the recycling of GFRP. It's essentially a big plas compactor, and the material is cut into smaller sections. We then shred it. Some of that we mix with an agglomerate, and then we put it back through the process. So absolutely, we can take a GFRP process here in Australia.
Fantastic. Thank you for that, Nick. And the next question, this I assume might be directed to SIS as well, and possibly to yourself, John, Robovoid, is: are there LCAs or EPDs from a reputable qualified person to support the carbon claims?
If I can talk on behalf of SIS to start with, we're about halfway through our EPD. And we hope to have that finished in the next 8 to 12 weeks. But so far, so good. I love the fact that Sasika did mention that we were still halfway through that process, but as soon as that's complete, that'll be published.
Wonderful. Thank you, Nick. John.
Yeah, and for Robovoid, we haven't gone through the EPD process yet, because it depends on you've got to get up to full production scale to get a meaningful assessment. So while we're in the scale up phase, we haven't gone there yet, but we will do. But in terms of the CO2 savings relating to savings in concrete, well, that's well understood by most professionals that less concrete means less CO2. So, and there's many recognised methods about calculating that. And I'm not sure if Sasika, if
Yeah.
you guys independently done that for.
So exactly. So we have been using the infrastructure sustainability material calculator to measure the carbon savings coming from reduction in concrete and reinforcement by using GFRP. Sorry, Robovoid and GFRP as well at this stage. In terms of the construction efficiencies and then the transportation, less transportation, and lightweight benefits, we have been like doing very high level calculations with our construction managers to understand how much it can improve the construction program, and based on that we have done the construction efficiency calculation. So yeah, for the GFRP we'll be having the as Nick mentioned, we'll have the fully approved third-party verified EPD. And then, as John mentioned, once the product is actually widely using, then we can look at getting the EPD just for the Robovoid. But what I'm trying to say is for the overall product, like a retaining wall, if you take the retaining wall as a one particular element, so the how we have calculated the saving so far is by reducing the concrete and CO2 coming from the reduction of concrete and reinforcement.
Fantastic. Thank you. And I think that brings us to all the questions, and with a minute to go. So everyone, can we please take a moment to thank Sasika, John, and Nick for coming along and telling us about what's happening on the project and their products. So a couple of Australian firsts on the way, which I'm really excited to see.
And Dewey, I would like to share the QR code
Yes.
outcome quickly. So this is what we got. So we actually have the high voting for the low carbon stormwater drainage solution. So probably that will be our next topic of discussion. Thanks all for voting for that.
Fantastic. Thank you. Saskia. Yeah, that's great. And I think it's drainage is always an area that obviously on our projects is such a big impact, and I think people are always keen to know more. So just to close out today's event, if you don't have access already, ecologiQ actually has a free knowledge hub that has it's a treasure trove of resources. So you can easily just drop us a line at ecologiq@roadprojects.vic.gov.au. We've got supply maps, case studies, a recording of this will be on our ecologiQ YouTube. And there'll be more Lunch and Learn sessions coming up every Friday for the month of May, with our last one on June 6th. So just keep an eye on your inbox. That should be coming out, if it's not by close of business today, on Monday with the next session. And we'll also have our Innovation Showcase series as well. And you can follow us on LinkedIn to find out more. And last but not least, if you want to learn more just about Recycle First and what's happening with the resource space, we're actually having our Greener Infrastructure Conference for 2025. And this will be on October 29th and 30th. There's a QR code there to scan and find out more. If you're planning on attending, it's free to attend. So this year's event will be partnered with Waste Expo. So it'll be at the Melbourne Convention Centre. And if you're a business a bit similar to Robovoid or SISA and you're keen to exhibit, I think that the exhibition hall and trade hall is still still has booths available. So I'm sure you can find that information there. But we hope to see you back at next week's Lunch and Learn, and maybe even in person at this year's Green Infrastructure Conference. So thank you again for coming to our Lunch and Learn this week, and we'll see you again on Friday.
Thanks all.
Thank you.
Next day.